Hi everyone, my name is Ruchita Kurapati and my teammates are Krishnavani and Pavitra. Now I'm going to explain about our project Plant Leaf Disease Analysis using Deep Learning. And coming to abstract, the timely identification and earlier prevention of leaf disease are essential for improving production, and it is necessary that leaf disease in plants should be detected in earlier stages helps to avoid the losses to agriculture economy. And deep convolution neural network models are implemented to identify and diagnose disease in plants from their leaves, since CNNs have achieved impressive results in the field of machine. So here we use convolution neural network algorithm to classify tomato leaf into different diseases. And coming to objectives, the main aim of the project is to detect the plant disease through some automatic techniques, and at very earlier stage itself it detects the symptoms of disease, that is when they appear on plant leaves. And the scope of the project is to develop a system that is capable to detect the type of disease based on deep learning techniques, and leaves of a plant can be used to determine the health stages of the plant. So coming to introduction, the automated identification of plant disease based on plant leaves is a major landmark in the field of agriculture. At earlier stage, detection is the basis for effective prevention and control of plant disease. In deep learning consists of different convolution layers that represents learning features from the data. Plant disease detection can be accomplished using a deep learning model. In deep learning also have some drawbacks, as it requires large amount of data to train the network. If an available dataset does not contain enough images, performance is worse. And coming to literature review, we have gone through certain general papers for better understanding and technologically difference between the papers. So the shown literature review gives that overall difference from our project to existing journals. In first paper, it discuss mainly about deep learning to detect the plant disease, but the project which deals has better accuracy output than this paper at about 97 percentage. And in second general, it deals with convolution neural network. It's similarly to project which we are executing, but we detect in every plant leaf than a corn leaf. This shows project which we deals has better efficiency. In the third and fourth general, it deals majorly about internal architecture in convolution neural network. We also deals with same architecture with better accuracy as extension. And coming to design methodology, we have four modules. Module 1 admin, it is first loading all the images in their respective categories from their directories. Then we are splitting the images into train and test in the ratio of 80:20, and images extracting features of images, maintain the database of leaf disease, start the CNN training. And second module is image data generator. It takes the images as input and it zooms the images, and it impacts on the accuracy of the model. And third module is CNN model. It arranging the multiple CNN layers and start the developing the model. It classifies the leaf images into different classes. And the fourth model is user. User inputs that images by using Tinker user interface and pre-process the input images, load the model into the program and view the related output. And coming to standards and policies, we have three standard and policies: framework and process for deep learning evaluation, standard for the deep learning based assessment of visual experience based on human factors, standard for technical framework and requirements of shared deep learning. Under these standards and policies from domain deep learning, we completed our project.
When we come to implementation, we are going to know about architecture diagram, data flow diagram, ER diagram, sequence diagram, and collaboration diagram. First, we will go with the architecture diagram. First, we have to give one leaf as the input to the database. After that, it will go for pre-processing and future pre-processing. Here, the database images are classified into two types: database images and training images. Database images means which are already there in the database. Training images means the developer have to give some images based upon the parameters and variables of the leaves, and after that it will go for random classification. If the leaf is normal means it will come with normal condition, and if the leaf is having any disease means it will come up with abnormal condition, and it will specify the disease name also. After that, this is the data flow diagram, ER diagram, sequence diagram, collaboration diagram, testing. There are five testing is there: unit testing, integration testing, functional testing, white box testing, black box testing. Unit testing means this is the software development process in which the smallest testable parts of an application are tested. This test is done during development process. Integration testing, it is also a software testing in which different units and components of an application are tested as a combined entity. Functional testing, this testing seeks to establish whether each application feature works as per the software requirement or not. White box testing, it is a method used to test a software taking consideration of its internal function. It is carried by testers. Black box testing. Black box testing consider the external behavior of the system. Testing also completed. After that, input and output. Uh, when we come to conclusion, this model also achieved an accuracy rate of 96%. When testing random images of plant varieties and diseases, the visualization of plots of train and test accuracy is described ensures the model is effective in detecting and recognizing plant diseases. Future enhancement, it will be very helpful in agriculture sector. It decreases the loss in farming, helpful for farmers, increases production rate. This is the poster presentation of the project.
Okay, here we are using Anaconda prompt. Why we are using this Anaconda prompt means the software is used for deep learning and also for the machine learning techniques, and we are using the 2019 software because it contains the TensorFlow work and Keras flow work. And then this is the this is our project details, and then we have to go to TinkTab prediction UI.ip and here this is the code. Here it is showing which type of disease means bacterial spot, early blight, lately blight, and then click run. If the star notation is showing here, then the project is running. And for this project, we have to install the requirements, and for that we have to install TensorFlow, Keras and this and all there in the Anaconda prompt. And then we have to install OpenCV.python. These are all the requirements for this project. And this is the tinter. Tinter is used to get the input and the output. And here we are having the select image icon. Then click on the select image icon. And here we are having the, and this is the tomato bacterial spot disease. And then just click it and then open. And here it predicts the which type of disease. Next, we can check and insert the healthy image. And here it, if the leaf is healthy, then it is showing the healthy leaf. This is how we predict the disease of the leaf using in this project. And that's all. Thank you.